Hey, hi YouTube, how are you? I hope you all guys are doing great. In this video, we are going to see functions in Python. This is going to be a masterclass where we are going to explore each and everything about function. This can be a one-stop video for you about if you want to learn or revise your functions in Python. Previously, we have also created a masterclass on strings in Python. So if you haven't watched that video, you can look at it. So this is all things which we are going to explore while learning about function in Python. So first of all, we are going to see introduction, then we are going to see definition of functions, then we are going to see parameters like positional, keywords, default, what are args and kwargs, because these are really important in terms of development perspectives, as well as if you want to crack any interviews. Even I have seen lots of experienced people don't know about args kwargs in a quite better way. Then we are going to see return statement, variable scope, like what is local, global, and non-local scope. Then we are going to see a PSRO, which is Python scope resolution order. Then we are going to see Lambda functions, built-in functions, what are the best practices that we should follow, what are decorators, and a bit about recursion also I will try to cover. I'm not sure whether I will be able to cover the whole things about recursion or not. Then some quizzes, okay, and for whom this can be a perfect choice. It can be a perfect choice for Python beginners or who wants to revise their functions in Python. Anyone who is looking to for a job or looking to level up their Python function handling skills. So let's start with the introduction on functions. Okay, and this is basically a one-page slider. Okay, and all the things, all the code that I'm going to teach you or show you will be available in this GitHub repo. I will definitely paste the link in the description box, and you can just clone it and use it for your reference. And this is my channel, so you can subscribe to it. Okay, so let's start. This is where we are going to learn about Python functions in Python. Okay, so first of all, we are going to see what actually function is. But before moving to function, I should create a virtual environment, and definitely in every I can say in every project we should create a virtual environment. It should become our practice. Okay, so I have already, let me just deactivate it. Okay, so currently my terminal looks like this, but I need to have a virtual environment. So what we can do, Python 3 dash m venv, and whatever virtual environment name I want. It can be .venv 1, 2, 3, anything. Okay. So now we have created a virtual environment. This is how virtual environments looks like. Inside bin there is a activate shell script which we have to activate it. Okay. So how we activate it? Source in Mac we do source ven sorry, the virtual environment name, which is .venv in my case, then bin, then activate. If you are on Windows, then just don't use source, just use .venv slash bin slash activate. Okay, and I'm here. Okay, so now my virtual environment has been activated. So virtual environments creates a virtual environment just for your project. So let's suppose in global level you have some different version of pandas or Python, but in your project you want to use a different version of the same package. You can use it. Okay, so first of all, we are going to see the introduction. So let me just create a file here, which can be 01 introduction. Okay, introduction.py. Okay, so first of all, let's see what actually is a function. A function is a block of reusable code. Okay, it works on dry principle. Do not repeat yourself. So basically, whenever we write some piece of code and we are knowing that it can be reused multiple times, we bind it into a function. So let's suppose we know that how to add. Okay, so let's suppose we have one variable as 10, we have another variable as 20, and we have to add it. So how we add it? X plus y, and then we just print it. Okay, print the result. If I just print it, what are we going to get? We are going to get 30. Now, I have taken a very basic example where we just write x plus y to add. But let's suppose just for addition, we need 100 lines of code. Maybe. Okay. So every time you have to add, you have to write that 100 lines of code. Is it a good practice? No. We want to write less code. It is easy to debug. It increase the readability. Okay. And also the dry principle. It says we don't have to repeat ourselves. Okay, because the logic of addition is always same. So why don't we create a method, okay, or a function. So this is how a function looks like. I'm going to I'm going to basically look at each and everything how what actually function looks like. But currently I'm just writing a basic function to give you a feel that how a function looks like. Okay. So this is how we have written a function to add. Okay. So this is basically a function to add some numbers. Specifically it's two numbers. Okay, but it can be anything. Okay. Now whenever we have to add, what we are going to do, result is equals to add, or maybe we can just call this add because we are printing there also, add 10 and 20. So now again if I run this we will get 30, but now the difference is whenever we have to add we don't have to write that 100 lines of code. Okay, I'm just taking a hypothetical situation where the result is, let's suppose, of 100 lines of code. So if we have to add two numbers, if it was 100 lines of code, then we have to always write that 100 lines of code. Instead we shifted that 100 lines of code into the method. Now even if we use that same method or the same function 100 times, it will just be inside this function. Okay, we don't have to write it 100 times. Okay, like 100 lines of code 100 times, we just have to call this. So this is how function helps us. Okay, so this is a block of reusable code which is basically based on do not repeat yourself, because we have just written that 100 lines of code here only at once. Okay, it improves readability and debugging also becomes easier. Okay, there are also built-in functions. Okay, this function that I have made is basically a user defined function because I have defined this function. I know how this function will look like. But if you see print, we haven't defined print anywhere, but it is defined inside the standard library. If you print, see, this is which is defined in the standard library, where you can see this is how a, a print method look like. It prints the value or to a stream to system.standard out by default. Okay, and definitely there are lots of things. Okay, so this is the difference between user defined function and built-in function. Built-in function that are already built by Python. Okay, whenever you install Python, it always comes with it. So you might have used print, len, which calculates the length of anything, then type to check the type of any data. So these all are built-in functions, and the function that we create, we call it as user-defined function. Okay, so this is how we define a function, and this is how we call a function. Okay, now let's see how a function definition looks like. This is what I gave an idea, but now let's see how function definition look like. Definition. Okay, function definition is very simple. You have to always write the def keyword, then you have to add the function name. Okay, sorry, function name, function name. Then you can pass any arguments, or we can say parameters, or if you can also leave it as it is. Okay, in the previous case, to add any numbers we definitely need something from user. It can be two numbers, three numbers, but there can be also a situation where we don't need any arguments. Okay, and inside this we have the logic of the function. In this case, whatever our logic, it was written in 3 and 4 line, so we have to add it and we have to print it. So this is how a basic syntax of function definition looks like. How we call a function, it's very simple. Just write function name or whatever function we have created, and then just call it. As simple as that. Okay, so this is how we define a function. Now let's create a function. So we are going to create a function which will greet the user. So greet. Okay, we are not passing anything. The name of our function is greet. What it will do, it will just print. What it will print, it will print hello. Okay, so it is going to just greet hello YouTube. Okay, so it is just going to greet. How we can call this function? The name of the function, greet. Simple. You can also check it here. Greet is a function. This is the definition, and it will return none. We will see what actually return is in the later half. Now, if I will print this, run this Python file, we got hello YouTube. So this is a very basic thing. Okay, this is first we have seen the function syntax, function naming conventions. We can see it later on. Okay, Indentation is really important. I can't do like this. Okay, so see, it is the ID is already warning me that okay, indent expected a indent in block. So we can have we must have indentation. So it can be this like, it can be also like this. Both will work. Okay, so indentation is really important. Whatever we write inside this method, a function should be in this line, in this with indentation of a tab. Okay, so that's it. So def keyword is really important, indentation is really important. You can have some arguments or you can also leave it. We will see how what is parameters or arguments. Basically parameters and arguments both are synonyms. Okay, don't get confused in it. Okay, so that's it, where in this video or in this section we have seen about the introduction part. In the next section we are going to see about function with parameters or arguments. In this section we are going to see about function with parameters. So let me just create another file 02, which will be function. Let me write it. Don't be lazy. Parameters. Okay. So parameters.py. So now let me create a function with a parameter. So we will use the same function which will be greeting. Okay. But now we want to add a name. Okay. So user will pass a name and we will greet him. So how we can greet him? So we will use f string. Okay. Hello and name. Okay, hello name. So this is how we are going to greet someone. So what actually a parameter is, parameter means we are trying to pass something inside this method. Okay, now if I just write greet and I pass any name, okay, John, and what it should print, it is printing hello John. We are using f string here. Why we are using f string? You can use any kind of string denotions. We have already covered in the previous video. F string is the modern way. Okay, and if I just remove this f string, what it should print, it will not take this variable. It will just say whatever inside, whatever we have passed inside this print statement, which is hello and curly braces name. But we want to refer to the same variable. And if I don't use this curly braces also, it will not work. Okay, I'm not going to touch a lot about in f string. You should know f string, or even if you don't know about f string, you want any other type, you are more familiar with any other type of denotation, you can also use it. Okay, so basically it is a function where we have passed some parameters. So parameters, sorry, let me just add here. So, or you can also say it as arguments. Both are synonyms. Sometimes I will use parameters, sometimes I will use argument. So don't get confused in it. Okay, both are same. Even I can call it as parameters, or sometimes I can call it as arguments. Okay. Now there are different types of parameters. Okay. It can be positional, it can be keyword arguments, it can be args, it can be kwargs, it can be default. We will see one by one each and everything. Okay, so first we are going to see is positional arguments. Okay, positional arguments. Okay, now what actually positional arguments are, you have to pass the arguments in the same order as the parameter are defined. So let's create a method, simple. Okay, again greet only. Okay, and let me just comment it out, greet, and I'm going to, instead of just name, I'm also going to pass age. Okay, and now I'm going to print as I have string hello, and I'm also going to print the name, and your age is the age. Okay, so now I am passing two things, name and age. And now whenever I have to call this, can I just pass the name? No, I have to pass both the things. If I just run this, see, greet is missing one required positional arguments, which is age. So we have to also add age. So let's add age. It's 20. So see, hello John, and your age is 20. So if you also hover over this, it is saying we have a function named greet, and it's taking two parameters, name, or you can say two arguments, name and age, and it can be of any type. Okay, basically this is any is basically a type hint. Okay, and how we add a type hint, because we know that name is always a string, so we can add a type hint here. We can add a colon and like this, and we know age is integer. So this is what we, the thing that we have added now is basically a type hint. So if someone some other developer wants to use your method, it will look, okay, this method name should be string and age should be integer. So this is what a type hint is. Okay, so type hint is not like Python does not, you can say it does not enforce types at the runtime. Okay, it is a dynamically, Python is a dynamically typed language. So even though you specified a data type, let's suppose you made age as integer, and even if you pass age as a string, even then also it should work. Okay, this whatever we have mentioned here, these type hints are just for the used by linters or IDs, or you can say other developers. It is basically helpful for them. Okay, so if even if I pass this 20 as a string, so it's not, this function will not stop or it will not give any error. Okay, so it's not like even if we made it as integer in other programming languages, it should stop it. No, Python is a dynamically typed language, so this will pass as a string only. But whenever we write a method, we should have a type hint so that it can be helpful for other developers, IDEs or linters. Okay, so this is how it works. Okay, so coming back to positional arguments. So what I have taught you, that you can pass arguments using parameter names in the same order as the parameters are defined. So if I just make it like this, 20, and let me make it as John. Okay, now let's see what will happen. Let me clear the terminal for this moment, and if I run it, hello 20, your name is John, because name is defined first, then age is defined later on, and we passed 20 first, so it was mapped with name, and the later we have had a John, it was mapped with age. So in this way it should not work, because um, we want as a positional arguments. So wherever we are writing positional arguments, we should be very careful that the arguments should be passed in the same order as the parameters are defined. Okay, I can say that whatever, whatever inside this we call it as parameters, and whatever we are passing we call it as generally arguments. Okay, so don't get very confused about it, but this is how it works. Okay, now coming back to keyword arguments. Okay, definitely, let me just revert it. Okay, okay, now we are going to use keyword arguments. I'm going to use the same method. Okay, keyword arguments, keyword, sorry, keyword arguments. Keyword arguments are, you can pass the arguments using the parameter names, and order doesn't matter. Okay, so now instead of directly writing John, I will add name is equals to John, age is equals to 20, because I know whenever I am seeing this method, I know that there is a name and age, and I have passed name and age. Now let me just comment it out and give it a run. So now we will get, hello John, your age is 20. Now even if I change the order, still we will get the correct one. Hello John, your age is 20. Because now we are directly saying to the method that I am passing name and age. And initially we were not telling, whenever we were calling the function, we were not telling that okay, name is equals to John. We were directly passing John. John can be, how the programming will know that John is name or age. But now we are mapping it. Okay, name is John and age is 20. So now the order doesn't matters. Okay, so this is the main thing. Okay, so this is the difference between positional and keyword arguments. In positional, order matters, but in keyword arguments, position doesn't matter. Now we want that, if we also want something like, if someone pass some name, we will use it. If someone is not passing some name, then we will say, we will fill it with guest. Or what we can do is, maybe we can take a better example. Okay, so let's see what we can do. I'm going to teach you about default arguments. Okay, what actual default argument is. So now we have name, then we have age, and if someone doesn't pass the age, I want the age to be 20. Okay, maybe in some case. Okay, so I want the age as 20. So now if I don't pass the age, okay, initially if we don't make any parameter as default, okay, let's suppose I am not making this parameter as a default, what will be the scenario? Are we able to call this method or not? If I run, let me just comment it out and let me just run it. So definitely it will throw error, because Initially also we have seen it because this function needs two parameters. See, greet missing one positional argument, which is age. Age is missing here. So that's why, because we have not passed age. But if we make it as default, okay, what default means, if someone is not passing a parameter, we want a default value. Now if I run it, so see, it doesn't break. Hello John, and your age is 20. So default parameter is like this. So whenever we don't want to, we want some default value of some parameters or arguments we pass, or we make our default values like this. Okay. And one more thing, if I make like this, okay, let me just like this. Okay, first I am writing a default arguments, and then I am writing the non-default arguments. Okay, so will it work? No, because see, non-default arguments follows default argument. So every time the non-default argument should be at the end. Okay, see, initially you have defined age, then all the other parameters if you want, and then the default parameters. Okay, so default parameters are very simple. It just holds a default value. Okay, whenever we are not sure whether user or basically even we don't want it, it's kind of an optional thing, and if someone is not passing it, we can have it as none, empty, or any default values. Okay, let's suppose you are creating a function for a school, and definitely if you are creating a method for any school or colleges, then the school name or college name will be simple. Okay, it will be always same, so it can be a default value. Okay, so that's it. Okay, so it is about default arguments. Now comes the very important part, which is variable arguments. Okay, variable length arguments. Let me comment it out, and let me call it as variable length arguments. This is really very important because a lot of time, even in interviews also, this is asked. So in variable length arguments, where we don't know how many arguments will be passed. Okay, so there are two ways. First one is args, and second one is kwargs. Okay, so first let's see about args. We call it as args. So args are basically extra positional arguments. Okay, so whenever we don't know like how many arguments will be passed, and it whenever we are passing, it can be a positional arguments. Already I have told you what is the difference between positional and keyword arguments. So when we are not sure how many positional arguments we are going to send, we use a args. Okay, so let's suppose we create a method, and this is going to add the total of whatever numbers we are passing. Okay, and we defined it as args. Okay, generally we write like this, asterisk and args. Then we can add, we can have some, okay, print, and or maybe result. uh, we can use some function. Basically it is a you can say user, not, it is not a user defined function, it is a system defined function, and which basically, see, this is basically returns the sum. So it returns the sum of the start value plus an iterable of numbers. So if we pass it like this, let's suppose the numbers, or I can say the args, so it will give me, it will have the sum of all the numbers that we are passed, and then we are going to print it. Now if I call this function total, and initially if I have 10, if I have passed 10, 20, 30, so it should print the sum as 60. Now I'm not sure, it can be any numbers, I can pass more, 50, 100, still this method will work, 210. Till now if you see this positional arguments part, if we have defined two parameters, then we can only send two parameters, we can't send one or more than two parameters. Okay, one can be possible if we make some parameters as default, but we can't send more. But in this case we are not sure, because user can add any numbers for the sum, because calculator doesn't know how many numbers are going to come. It can come n numbers, but it can give the sum. So in this case we are passing whenever we are not sure how many arguments, how many positional arguments are going to passed. So this is positional argument because we are not adding any keywords here. Okay, and this arguments is passed as a tuple. Okay, so if I just add, if I just print, okay, args, so here you can see, let me just clear it. So this is a tuple, okay, and we are getting 210, okay. So this is about args. And one more thing, is it mandatory to write always args? No, you can write anything. Write numbers. You can name it as numbers. Okay, it completely depends upon you. It's a variable. Okay, so still it works, but generally we use args. Okay, in industry we use args only. Okay, clear. So this was about variable length arguments. Whenever we are not sure how many positional arguments we are going to have. Okay. Now, in the same manner, uh, let's take another, which is this is also a part of variable length arguments, but it is quarks. Similar to args, we also have quarks. Quarks are basically used to accept any number of keyword arguments. Okay, when we are not sure how many arguments we have to send, but not positional, we want keywords, then we call it as we pass it as quarks. So let's suppose um, I want to send a profile where I want to send the name. Let's suppose the name is Neeraj. I am sending age. Sorry, I'm sending another parameter argument as age, okay, and 20. Now I want to accept it here and I want to greet it, or I want to show that user. Okay. Now I'm not sure how many keyword arguments are going to come. So I mark it as quarks. Okay, quarks. And then I can just print the quark. Nothing else. Okay. Simple. This is show user. Okay. So now if I run this method, it will show me name is Neeraj, age is 10. We are getting a dictionary. So can you infer something from this? Yes. Whenever we are passing a quag, it comes in the form of dictionary. In case of arguments, it was coming in the form of tuple. But in case of quarks, it comes in the form of dictionary. Okay. Now, what's the benefit of it? If I add here, let's suppose I add a city. Okay. Still it should work. Okay, Delhi. Okay, so if I run this, still it works. Name Neeraj is 10, city Delhi. Why it is working? Because we have passed as a double asterisk and it is quarks. So whenever we are not sure about how many keyword arguments we are going to use, we pass it as quarks. Whenever we are not sure how many positional arguments we are going to send, we name it as args. Okay, and definitely if it is a dictionary, and one more thing, you can name it again anything. Okay, you can name it as user info. Okay, you can name it as anything. Okay, it's not like every time you have to use quarks, but just as it's industry standard that whenever we are passing n number of positional arguments, we call it as args, and when we are passing n numbers of keyword arguments, we call it as quarks. Okay, clear. And this double asterisk will always in the definition part only, not whenever not even when you are calling, or not even when you are accessing it. Okay, so let it be quarks only. Okay, and definitely if it is a dictionary, you can also print like this. For you want the key as well as value in the dictionary. Key value in what the dictionary we are having. Quarks is basically a dictionary, because whenever we pass the keyword arguments, we receive as a dictionary. Whenever we pass at args, we receive it as a tuple. Okay, so we can print it also. Okay, so we can print the key, uh, something like this, key and its value, key and its value. Okay, so we are calling it as val. So we can just remove this line. Now, whenever I will print it, let me just clear it. Key value in quarks, too many values to unpack except expected two. Oh, sorry. So whenever we are dealing with dictionary, we should do like this, because we want the items. So see, name Neeraj, age 10, city Delhi. Okay. Why we are able to do this line? Because in Quarks we receive it as a dictionary. So that's why this is a basic operation of dictionary whenever we have to iterate over the dictionary. So we are getting the key values in all the items of dictionary, and then we are doing this. Can we do this same two lines in args? No, because we are not receiving args as a dictionary. We are receiving the args as a tuple. Okay, clear? So I think this should be clear about args and quarks. When we don't know about how many positional arguments we have to send, we pass it as args. Name can be anything. It's not mandatory. Just asterisk is mandatory. Asterisk, it can be numbers, it can be anything. The extra positional arguments that we send, it is received as a tuple. Okay, what is kwargs? When we don't know, when we are not sure how many keyword arguments we are going to send, or the function is going to receive, we call it as kwargs. Again, double asterisk is mandatory, but the name, the variable name, it is not mandatory to be always kwargs. It can be anything. Okay, and we receive the keyword arguments as a dictionary. Clear? I think this much is enough about args and quarks and about the parameters. So we have seen positional arguments, keyword arguments, default arguments, args, quarks. Args and quarks are really most asked question in an interview. Okay, so let me just clear it. Even in experience interview, sometimes even ask whether to look whether they know it or not. Let's have a quick question. I'm creating a method here and you have to tell what will be the output. Okay, you have to pause the video and you can tell the output what should be the output to check whether you have understood or not. Okay, and if you're not practicing with me, it's your fault. Okay, you should practice with me, because if you will not practice it, I don't think so you will grow anymore. Okay, so we are creating some function like this, uh, and mm, we are also going to print the args as args. Print we are going to print the quarks also as like this, quarks. Okay, now I'm calling this function, which is a test one, and I'm adding 10, 20, 30, 40, x is equals to 10, y is equals to 20, or maybe 200, and let's make it as 100. So just pause this video and try to guess what should be the output of this program. Okay, so we got this output because first we have passed 20 and 20 has been mapped to A. Then we also have a parameter, which is basically we have added a default value. So if you see here, somewhere here we have also added a default value. Default value means that if someone is passing some value, we will use it. If someone is not passing that value, we will use the default value. So we have passed second parameter 20 will be mapped to B. Then the rest positional arguments. What are the rest positional arguments? This is 30, 40. So it has been passed as arguments. Now the rest are the quarks. Basically, these are the keyword arguments, but we don't know how many numbers are there. If I add it here, like z is equals to 300, so it should also work. It should also print the same 10, 20, and in args we have 30, 40, and in quarks we have 100, 200, 300. So this is what the output should be. Let me know how many of you have guessed correct. And also, one more thing is very important. Order must be followed. First, we should write positional arguments. Then we should write default arguments. Then we should write um, the args part. Then the keyword only arguments, and then the quarks part. Okay, this position is really this sequence is really important. Let me write it. First, there should be positional arguments. Then there should be default arguments. Then there should be the args part. Then there should be the keyword arguments. Okay, so keyword only arguments. Okay, then we should have the quarks. This is really important. That's why you can see first we pass the positional, then we pass the default, then we pass the arguments. Definitely we have not passed keyword only. Then we move to quarks. So this is how the order we should always follow. Okay, and this can be also a very good interview question. Now, you might be thinking that where this keyword arguments or arguments are, we use it. Okay, basically keyword arguments or arguments are heavily used in decorators. Okay, and it is used to pass arguments or keyword arguments to another method. Okay, so let's suppose there is a method, original method. Let's suppose it is taking two thing a and b, and it is just printing a and b. Okay, it is printing a and b, nothing else. Okay, it is printing a and b. Now, whenever we call this function, it will print a and b. But what if we want this functionality, but having a wrapper? Okay, what I mean is there will be a wrapper function. We don't know the original function can have any number of arguments. It can be have n number of arguments. It can be having n number of keyword arguments. We don't know. So for this wrapper, we take this as args and also as a quarks, and then we pass it to the original function, the same args and quarks. Because how we will know that this original function can be later, it can be modified. Okay, it can be modified by some developer, and instead of abc, it's now taking um, a b c d e or any keyword arguments. Now if I call this, even if I call this wrapper with 10 and 20, it should work. So if I just clear it, so we are calling this wrapper, and this wrapper is taking these arguments as args, and because this is positional arguments, and it is giving it to original. It is passing to the original function, and it is printing. So this is how it is used, because we have created a wrapper. Okay, and this is heavily used in decorator part. We will see what actually decorators and all in the later half. And even if I make it as 30, okay, and maybe it is now taking ABC. Okay, and I pass 10, 20, 30. It should work. So this is how it is used. Okay, to pass the arguments or keyword arguments to another method, we generally use this args and quarks heavily. Okay, so maybe it can be a bit confusing for you, this keyword and arguments part, but I don't think so. This positional keywords and default arguments will be very tough for you. Please practice it, and if you feel a bit confusing, just go and rewind this video. You will definitely have all of your answers. And definitely just don't see this video, please code along with me. Try this all thing. Okay, try some scenario like, can I create a function for finding a number is even or not? Can I think of a function which can uh, print even numbers between the range? Let's suppose I give you a question, create a method, take two inputs, like two numbers, like maybe 2 to 10, 2 and 10, and you have to print all the even numbers between 2 to 10. It can be 2, 4, 6, 8. Okay, so this type of question, think of yourself and try to use it. Okay, so this was about functional parameters. Now in the next section we are going to see about return statement. Okay, so let me create a third part with the return.py. So this is in this part we are going to see what is a return statement. Okay, so basically whenever we are writing a function, we also try to return something. Okay, so let's suppose again we created an add function which takes two things. Okay, a and b, two values. It can print something. Okay, it can print the result, like it can be, let's suppose res, we have added a plus b, and we can print it, and whenever we have to call, we can write something like this, 10 20. It will print 10 20 is 30. But instead of printing here, we can also return it. Okay, instead of doing this, we can also write like this. Okay, follow the indentation, return res. This function is going to return something. Now if I do like this, what will happen? Nothing will happen, because see, nothing happens because this function is returning something, so we should receive it in some variable. So if I write this sum is equals to this, and then if I print it here, sorry, if I print it here, I will get the 30 part. See, I got 30. So if I see this now, so we have a function which is add, and it is of a, it will receive a b, and it can return anything Okay, but definitely it is returning something. So there are lots of cases where we don't want to print inside the function. We just want to give some arguments or keyword arguments, and then we are trying to get some output. Okay, and in the main function or the main code, we are trying to, we can see we have to print it or we have to send over the networks or whatever it is. Okay, but that's why function should uh, or a function can have a return statement. Okay, if you have a print, it will print inside the method. If you uh, are returning something, it will not do anything. It will just execute the logic and it will return it. And definitely whenever it is returning something, you should have a variable to receive it. Okay, and definitely we can add type hints, like integer can be integer, a can be only integer, b can only be integer. We can also add a return type here. Okay, so it will always return, sorry, it will always return integer. Now if I do like this, see, we have made a function which is add a, which can be of type int. It is just a type hint. Okay, you can also pass a string. Okay, b can be of int, and this function is going to return a integer. Okay, so if I run this type hint is not going to help in this program, but it can be a good thing for linters, for other developers. Okay, so this is how you can also add the type hint for return type. So which type of value are we going to return? This is a type hint for it. Okay, just look at it. Okay, so this is what return is. Okay, return is very very helpful because in lots of method we don't print it. Till now we were printing inside the method, but generally we return something. Okay, so that's it on return part. In the next section we are going to see the scope of the variables in a method, and we are going to see scope of a variable inside the function. So what is actually a variable scope? So there are different types of scope. It can be local, global, non-local, whatnot. So let's see what actually scope is, and we can have an idea with this code only. So let's suppose we have a variable which is, let's suppose x is equals to 10. Okay, can I print it? Yes, why not? You can easily print it. So let me print it. Okay, 10. Now let's suppose I have a method, and the name of method is change, and inside this I have created a variable which is y, its value is 20, and I am trying to print it. Okay, so would I be able to do it? Why not? Okay, let me call this change function. Okay, sorry, what happened here is, what is happening? Control D. Okay, sorry. So now we have a variable x is equal to 10. We have a method which is having y is equal to 20, and we are printing it. First we are calling x, so it should print 10. Then change method we are calling, so it will print y as 20. Fair enough, no problem. But what I want to teach you is, let's suppose I try to print y from outside. Now what will happen? Definitely it will throw error that name y is not defined. But you see, okay, y is defined at fourth line, why it is not able to print at seventh line? Because this y variable is defined inside this function. This is how the program looks like to y. This seventh line looks like this. Okay, I have a x, but where is y? Y is inside this method. So this, the, you can say variables which are declared inside a function is called as the local variables of that function. It is accessible only within that function. So y is accessible only inside this function, not outside. Okay, and x, this is a global variable. So let me name it also. This is a global variable. So this variable is declared outside all the functions or block, and is accessible throughout the entire program, entire file, including inside the function also. You can also access this x inside this function. Okay, if I print like this, print x. Okay, so now this method will print everything x and y, so I don't want this line. If I print it, see, x is 10 first line, y is 20 second line, and this one was local variable. Okay, so global, is which is declared outside all the functions. And what is the lifespan of this global variable? Until and unless this whole program ends. But what is the lifespan of this variable? If this method has, let's suppose we call this method, this function, it creates a variable y, it prints it, and it destroys it. So the lifespan of a local variable is the lifespan of the block or the lifespan of the function. Okay, function don't takes any space. It takes a space when it is called. When this function will be called, then y will be created. Then all the variables inside this method will be created, and then only it will occupy some space. Okay. Now you will say, uh, this x is 10, y is 20. We are printing x is x here. Okay. What if I do like this? Okay. I'm printing this x here. Okay. Now what will happen? X is 10. We are making x is 20, and then we are printing x. So let's see what will happen. So we got as 20 because we have modified the x as 20. But if I um, print x again, will it be 20 or it will be still 10? Okay. So, oh, interesting, this 10. Why? Because initially x was 10, then it doesn't assign it, but it created a variable x as 20. So it created a variable x and assigned 20, and it printed it and it destroyed it. And already we have a x is 10, so it printed that x is equals to 10. Now, if I want to access this variable directly, so what I can do is I can do global x. Okay, cool. Is it fine? Okay. So now if I do this, let's see, we got 20 and 20. So this x is 10, which is a global variable. Now, once I add this line global x, so I am able to access the global variable from the block level, from the function level. And now I am assigning this x to 20, means this 20 is being assigned to this x only. Okay, initially it was not happening. I call this method, I got first I got this x as 20, it printed the value as 20, and as we were referring to global variable only, so this 20 has been stored to the global variable which was at the first line. That's why the whole value of x has been changed. Okay, this is the thing. This is the difference between global and local variable. Variables which are declared inside a function is local. It is accessible only within that function. The time, the lifespan of local variables are the lifespan of the block. Once the block is exhausted, the variables is destroyed. Global variables are the variables which are declared outside all the functions or block, and is accessible throughout the entire file, including inside the functions also. The lifespan is entire function or entire module or package. Okay. And what is non-local keyword? So non-local keyword are used inside nested functions to modify the variables in enclosing or non-global scope. Okay, I know this might be a bit confusing for you. Okay, so let's create a outer function. Okay, so let's create a outer function and let's create x as hello. Okay, now let's create an inner function, and inner function, this x is now a non-local, it's not a global, because what I told you that global are declared outside all the functional blocks, but this x is only global to this inner. Okay, it's non-local, we can say, we can't say global. So non-local x, so for this inner method this x is a non-local, because what is local to this inner function? All the function or the variables which are inside this inner, but this is non-local. Okay, then x is equals to, sorry, non-local x is equals to world. Okay, now basically what we can do is we can call the inner and we can print it, simple. Okay, and let's call the outer, because outer we can call the outer. Okay, see, now what will happen? We got world. First we called the outer, we went to the outer, we see x is equals to hello, then there is a definition. Okay, definition doesn't executes first. Okay, we call this inner has been called, and we are referring to a non-local x. Initially we were using global x because it was outside all the blocks, but it is outside this block but inside a block. The x is outside this inner block, but it is out, it is basically it's non-global, it's, or you can say it is non-local to this inner. That's why the name came non-local. This x is local to outer, but it is non-local to the inner function. So we are accessing it and we are changing it, and finally we are in inner, we are getting print x, which is this x is 1. So if I don't use this x, okay, this will be easy. So definitely we should get hello, because we call this method which has x as hello. This is the definition of the function. We call this method and it created a variable x and it assigned world, and that as this method is, this function has been destroyed, it has been called out. So the x which is inside this, which is local to this inner, has been destroyed now. So x is only having hello, so we printed x, which became hello. But once we used it, so what is happening, it calls outer, it creates a variable, it is referring to this x only, because it, we are like globally we are to access the global variable, we are doing global the variable name. Similarly non-local, we are doing non-local x, and we are assigning world into this same is this variable only. So that's why when we are printing it, we are getting world instead of hello. So these are the three things which you should know: local, global. Non-local is not that useful, or I can say it is useful, but it is not that much famous. But definitely you should know about local, global, non-local. Local variables declared inside the function, global variables declared outside the function, a block. Non-local used in a nested functions to modify the variables in enclosing or non-global scope. Okay, so that's it about I can say um, scope. But I remember one thing, I have to tell you that there is a Python scope resolution order. Okay, so wow, this is not that much important, but someone can ask you PSRO, what is PSRO? So this is basically Python scope resolution, resolution order. It is also called as LEGB rule. Okay, okay. So L is for local. First priority is given to local variable. Then the enclosing or inside enclosing function in a nested function. Okay, the priority is given to that function, that variable. Then the global, which is top level script or module variables, are given the priority. And then we have built-in Python built-in functions like length, print, and all are given the priority. Okay, so in this case, if you see this method, okay, if there is any variable which is inside this, so this will be given the topmost priority. Then is there any or maybe it can be better if we take this example. Okay, so let's take this example. This is much more easier to explain you. If you see this inner one, so first of all it will give priority to whatever variables are inside this inner function. Then it will look outside, so it will get a non-local keyword, non-local variable. So second priority will be this. Then it will look to global variables. The third priority will be this, and fourth priority will be all the built-in functions like length, print, or whatnot. Okay, so this is not really important, but you should know this LEGB, that first is local, then enclosing, then global, and we have the built-in functions. Okay, so this is how LEGB rule works, or Python scope resolution order works. Okay, or what I can do is maybe let me give you an example. Okay, so let's suppose we have global. Okay, and then we have outer, and inside outer I have x as enclosing, and I have inner method, and in inner I have x as local. Here I'm printing the x here, and I'm calling inner from here, and at the end I'm calling the outer. Okay, so now let's execute this and see what is happening. So we got local. Why we are getting as a local? Because the topmost priority of this function is this local one only. Okay, if I just remove this, okay, now what I will get, I got enclosing because the second priority is of enclosing. Okay, if I just also comment this, now I will get a global because the third priority is global one. Already with them we were having multiple x, but initially the priority was more to the L because we have LEGB rule. First was local. When we commented it, it the priority shifted to enclosing one. Then the priority shifted to global one. Okay, simple. Okay, so this is how this rule works. This is not really important, but maybe in some of an interview someone can ask to just trick you. And sometimes interview is on a bad mood and they try to ask some questions which are really they have no relation with the real development that we do. But so for tackling such a situation, you should know it. Okay, like MRO, method resolution order. In a similar way, you should also have you should know Python scope resolution order. Okay, so this is kind of a really important thing. In the next section, we are going to see lambda function, which is really, really, really important. So let's meet in the next section. We are going to see about lambda functions. It is a very, very important topic. Lots of time I have seen in an interview, if someone is asked about lambda function, they don't answer it correctly. And even when they are studying, they feel like lambda function is out of this world and they frightened from this topic a lot. But it's a very simple topic. You just have to give some focus to it. It's much easier. Okay, so let's see what actually lambda function is. Okay, so lambda function is basically a one line anonymous function. That's it. It's a one line anonymous function in Python. In Python, a lambda function is a small anonymous function defined using a lambda keyword. Unlike a regular function defined with def keyword, a lambda function does not require a name and is typically used for simple one-time operations. Okay, it's anonymous. It means that they don't have a formal name like functions defined with def. Every function has some name, but this function doesn't have a name. A single expression, a lambda function can only contain a single expression which is implicitly returned. It cannot contain multiple statements or complex logic. It's concise. Their compact syntax make them suitable for inline use, especially as arguments to higher order functions like map, filter, or sorted that we are going to see. And they can have any number of arguments similar to regular functions, but they can have only one expression. Okay, so what actually is the syntax of lambda function? We have lambda keyword is used. Then we have expression. Okay, sorry, no, we have arguments that we have to pass, and then we have the expression. As simple as that. Let's see how we can use it. So if we have to add two numbers, what we do, sorry, a and b variable, and then we return a plus b. So this is a very basic, you can say, function that we have. Which sorry, return a plus b. So this is the method which takes two arguments and return the addition of it. So how we call it as res is equals to add 10 and 20, and then we sorry print the res. If I print it, I got 30. But can I do it with lambda function also? Because this expression is very simple, this a plus b. Yes, why not? We can do it. So how we can do it? It's simple. We don't have to write this many things. Just comment it out. Instead, here we can write a lambda function. Lambda, it will take two parameters, a and b, and it will return the uh, addition of it. So we have the keyword lambda, then we have the arguments a comma b, and then we have the expression. Now if I run it, still I will get, oh, now I'm getting basically, I got the lambda object, okay, but I have to pass it. Okay, so what I can do, res 10 comma 2, okay, and this should be stored somewhere because it is going to return the a plus b, and if I print sum here, I will get the answer. Okay, so now I got 30. Initially what it was, because res is pointing to a function. Okay, this is a function, so we got a function object, and the function object was this was the lambda function object, but we have to call that function. So that's why this function is stored in res. You can think like that, but actually this res variable is pointing to this lambda function, pointing to this object. And then when we pass 10 and 20, it is passed to this lambda function 10 and 20, and it is returning a plus b, which is 30, and we are printing it. Okay, this is anonymous because initially we have to give a name to this function which was add, but this we don't have to give a name to this function, and we don't have to use even the def keyword. This is a very cool way to write functions, or to write simpler expressions or simpler functions. Okay, let's try something. Okay, it will be fun for you. Let's suppose we have to write a I can say a lambda functions where we have to find the square of number. Okay, so square of number, we have to write a lambda functions. It should give us the square of the number. Okay, so let's call, we are going to store this lambda function here. We have to find the square, so it should take one argument, and what it should return the square of it. Okay, or you can do this one also. Okay, so now if I call this print square 5, okay, instead of storing this variable into another variable, or the result of this method into another variable, I can directly also pass it here. So I have created a method, or you can say a lambda function, which is taking this 5, and what it is doing this. This is the expression it is performing, 5 into 5, which is 25. So if I just let me just clean it a bit, and if I run it, I got 25. Okay, let me do like this, it will be much clearer to you. Okay, so this is how we can write a lambda function for to finding a square of number. Okay, simple. Okay, I think it's very simple. Now I told you that we should generally we use this lambda function, um, basically because of their complex syntax. It makes them suitable for inline use, especially as arguments to higher order functions like map, filter, or sorted. Okay, so how we can use it, let me tell you. Let's suppose there is a case where you have a list. Okay, let me call this use of map function. We can use it map function. Okay, let's suppose we have nums. Let me comment it out. Okay, so let's suppose we are going to have a list of nums. Nums with, like, let's suppose two, maybe 1 2 3 4 5. We have to find the square of each number. Okay, or each, let's suppose we have to find the square of each number. Okay, map is generally used to apply some function to every item. Okay, okay, simple. And we have to define the function also. So what we can do, map, sorry, I can say square, sorry, square is equals to map. Okay, what does map do? I have also revised it in the previous one. It takes a function and an iterable. Iterable means it can take a list, tuple, whatnot. Okay, so we have to pass a iterable, and sorry, we have to pass a function. Sorry, we have to pass a function and iterable. So here we will add a function, and we have already added a iterable. Iterable means anything that can be iterable, that can be iterated. List, tuple, dictionary, all are iterables. Okay, we have also seen in the previous video. Okay, so map, we have function and we have iterable. But so this map will take this iterable and perform some function on it. What will be the function? Either we can create another function with def keyword and all, but we just want to have a square, so it can be a very simpler function. So we can write a lambda function here. Lambda, it will take whatever argument it will take, it will give us the square of it, that we have already seen. Simple. Okay, that's all. Okay, if I print the square, okay, there is a catch. Let's check what it is happening. So it gives us a map object. So this is giving a map object, but we want the answer is in the list. So we will typecast it. We will convert it into a list. Simple. Okay, there is no big thing here. So now I got a list with square 1, 4, 9, 16, 25. Okay, because see, the map returns a map object. Okay, see this map is taking a function which we passed as a lambda function. This map is taking iterables. We have passed iterable, which is a list, and map returns a map object. So that's why we have to convert it into a list. So that's why we converted it into a list. Okay, as simple as that. Okay, so this was about map. Next, so why I am teaching you this some methods, because to show you where this lambda function is basically used in daily life. Sometimes this feels very confusing, but this is what you have to tackle if you want to become a software developer and if you want to crack some good interviews. Okay, filter. Filter is basically a method which filter elements based on the condition. Whatever condition is given, it will filter out. Okay, map was applying the function to every item, but filter basically does the filtering, filters the element based on the conditions. Okay, so let's take the same nums. Okay, let's take the same nums and we have to just filter it. Okay, and after filtering we are going to get the evens number only. Okay, so filter. Okay, let's see what filter is taking. You can take help of it. Okay, it takes a function and iterable. Okay, so we will write some function here, but let's add the iterable, which is nums. Now we want a function that will filter only the even number. Okay, that's all. Simple. So we will add lambda. It will take x, and if it is a even, so this, it will return true. So it will take x and it will perform this expression. See what it is happening. If we add 4, 4 modulus 2 is equals to 0. So this will return a true. It means that the number is even. If we have 3, 3 modulus 2 is 1. So 3 modulus 2 is 1. It's not equals to 0. So it will give false. So in that case, this will be filter out. And definitely filters also return a filter object. So we have to convert it into a list. Similarly, the way we have uh, done with map. Okay, sorry, a list. And now if we print the evens, we will get the answer. So let's print it. 149. Sorry, I was shocked. Okay, so if I print this, I'm getting 2 and 4 because 1, 2, 3, 4, 5. Based on these numbers, we have to filter only the even numbers. So even numbers is 2 and 4. Okay, if you're not understanding this expression, it's very basic that we have given an argument x and we are checking whether it is even or not. How we can check whether it is even or not? Modulus 2. If modulus 2 is 0, that number is even. Okay, because it's not giving any remainder. Okay, okay. Now we have also seen, we can also see sorted. Okay, sorted is basically sort based on a custom key. Okay, so let me explain you what exactly I want to say. Okay, so let's suppose we have students and we have a list of students. Okay, we have a list of students and inside this we have a tuple which have some name 1 and maybe some marks, let's suppose 88. Then we have another one as name 2 and marks is 89. And we have maybe we have name 3 marks as 45 and name 4 whose marks is, let's suppose, 78. Now let's suppose we have to sort it. Okay, so how we can sort it and where on which key we can sort it? Definitely we don't want to sort on the base of name. We want to sort based on the second key, which is denoting some marks or attendance whatnot. Okay, so how we can do it? So sorted students, let's suppose we are going to store it at sorted students and we will use sorted. Okay, now let's see what actually sorted does. It takes a iterable and a key and reverse true or false kind of thing. Okay, if you make reverse as true, it will give in the reverse one. Okay, like when you sort something, it does in ascending order. But if you do reverse is equals to true, it will give it us the result in descending order. Okay, if reverse by default it is false. See, this is a default parameter. If you don't pass default, if you don't pass reverse, it is false. Means it will give us the results in ascending order. But in this case, if we want to see, let's suppose the second parameter is marks. So we want to see the highest marks at the top. So we have to make the reverse as true. Okay, so it takes a iterable first. So iterable will be students. Okay, then it takes a lambda function. Okay, or you can say function. See, sorted sorry, a key, okay, and a reverse. It takes a iterable, a key, and a reverse one. Okay, so students, and then we have to give a key. Key is basically a function. Okay, so the function, whenever, let's suppose we are taking this element, then we will take this element, then we will take this element, then we will take this element. So every time we have to take the uh, at whatever element which is at one index. Okay, we don't have to perform any operation on the first index. Okay, so we can create a lambda function which will take a parameter, and you can say a tuple, and it will give the value which is at one index, and we have a reverse as true now. Okay, so let's print it, and then maybe I can explain you much. Okay, sort it, students. Let me just clear it out. This can be a very good question. If you have to, if someone asks in an interview, you have to sort a tuple in increasing or decreasing order. So we got it in the decreasing order. 89 at the top, 88 at the second, 78 at the third, and 45 at the last, last fourth. Okay. So what it is doing? Okay, sorted takes a iterable. We gave a iterable. Also, we then sorted takes a key. So key is basically a function. So at one time, if we have a iterable, it will iterate. First, we will get this element, which is a tuple. So at what index we want to apply the sorted operation? We want to apply it on the second, or sorry, second element, but first index, because name is at zeroth index, 88 is at the one index. Name 2 is at zero index, 89 is at the one index. Don't think the whole list as input. Okay, it will take one by one. First this, second this, then then this, and then this. So every time we get a tuple, it will return the value which is at one index, which will be first. For the first, it will be 88, then it will be 89, then it will be 45, then it will be 78, and then it will sort it, and we made the reverse as true, means it will be in the descending order. So that's why we got 89, 88, 78, 45. So these are the use of lambda functions. Okay, so we can use directly, we can use with map functions, filter functions, sorted functions. If you find a bit confusing, please revise this part, because a lot of time people feel this part as a bit confusing part. Okay, but what are the limitations of lambda function? Only one expression is used, so no multi-line logic are written here. No statements like if, try, or while. It's harder to debug or write doc strings. It's not good for complex logic. We should use def instead. Okay, so that's it. So we have seen what is lambda function, how we can use it, how we can use with this map, filter, and sort it. This can be a very good question. If someone is given a list of tuples and you have to sort it, if you know lambda functions, just one liner. Okay, so just revise this whole part. We have seen also the limitations. This section we are going to see some of the inbuilt functions and their uses. Okay, so inbuilt functions are the functions that are already defined. We don't have to write the definition of that function, like print, sort it, map. All these are inbuilt functions. Okay, so I want to give you some introduction to some of the main inbuilt functions. I let me tell it call it as IB functions. Okay, these are really important. Okay, sometimes it helps a lot while solving some challenges. Okay, so first one is a zip. Okay, very useful. So zip combines two or more iterables into tuples of corresponding elements. Okay, let's suppose we have a name. We have a list of names. Let's suppose Zaki is a name, and we have anything Ram as a name. Okay, and we have their scores. Okay, and we have score of like 90 and 90 67. Okay, we want to combine it into tuples. Okay, list of tuples, I can say. Okay, so let's pair it, paired, and we are going to use zip. See, zip takes two iterables. Okay, so and zip objects is n length tuples, where n is the number of iterables passed as a position arguments to zip. Okay, you can read it. Okay, so we pass the names, and we are also going to pass the scores, and then we will print the paired. Okay, And definitely the zip returns are basically a zip element, I think. So we want a list of tuples. So if I just print this, okay, so here you can see we got a zip object like map and all, as we have seen already. So we will typecast it to a list. So now see the magic. We got Zaki mapped to 90 and paired with 90 and Ram paired with 67. Although both are independent. So sometimes this type of things becomes really, really important. Now the next one is again really important one, which is enumerate, and I'm damn sure that you are going to use this. Okay, it adds an index to each element in a iterable. Okay, let's suppose you have a list of colors. Let's suppose yellow, green, whatnot. Okay, let's add one more color, maybe black. Okay, black. What's your favorite color? Okay, so we have another color which is black, and now either we can iterate or we can also provide a we also want a index with it. Okay, so how we can do it? For if we just have to print the color, okay, so color in colors, and we can simply print it, isn't it? Print the color. Okay, sorry, print the color. Okay, let me just comment it out. So now if I print this, I got color black, yellow, green, but I also want the index of it. Okay, I also want the index of it, so I will add enumerate here. Okay, enumerate is a built-in function. Enumerate, it will gives us two things. First it will give the index, and second it will give me the color. Okay, the elements, so I can print it. I can print both index as well as color. So it will be something look like this. So at 0 we have black, at 1 we have yellow, at 2 we have green. So it gives the index, okay, to each item in the iterable. Okay, can be really helpful in some scenarios you will face in future. You want, if you want the index as well as with the element. Okay, if you want both the things, then there is any. Okay, it's it can be also simple, but it can be helpful. It checks if at least one element in the iterable is true. So let's suppose we have flags, lots of flags we have. Okay, we have true, we have false, we have false. It checks if at least one of the element in the iterable is true. So if I just do print any and flex, okay, so is there anyone true here in this list? Definitely there is one true, so it will give us true. If I make this, remove this true, it should give us false, because now there is no true. Okay, it checks, any basically checks if at least one element in the iterable is true. And similarly there is all. Okay, all basically by the name, it it can easy to decipher it that only if all elements in the iterable are true. Okay, so if I just do like this and I make it as all, and if I do this true, so one of them is true but not all of them. Okay, so any one of them is true but not all of them, so it will give me false. It will give me true only when all of them are uh, true. Okay, so it gives me now, gave me now true. So all, only if all elements in the iterable are true, any if at least one element in the iterable is true. Enumerate basically adds the index to the iterable, and zip basically combines two or more iterables into tuples of corresponding elements. Okay, as simple as that. Now let's see what are the some best practices that we should keep in our mind. Okay, this is really important. This is not mandatory, but it's good to know. Always we should keep functions names meaningful. Okay, if you are from any programming background, Java or something, we should name the functions very, very smartly. Let's suppose there is a function which is maintaining your wallet balance. So the name of the method should be def um, maintain wallet balance instead of something random like balance wallet or something not meaningful. Okay, it should be very very meaningful. Okay, you should not name something which is not meaningful. Okay, always one function should be assigned one responsibility. It's like one function should not be assigned multiple responsibility. Let's suppose you are making a function to add two numbers, so only one, that method should only add numbers. It should not do any other job like multiplication, finding prime, even finding prime numbers, finding even or odd numbers. It should not do like that. So one function should always have only one responsibility. Always you should use doc strings. Okay, if you are not aware about doc strings, so let me tell you. Let's suppose there is any one function that we are, so okay, so let's take this function. Okay, so what this function is doing, it is printing, it is greeting to the user. So how we add a doc string is simple. We add triple quotes and like this, and we write what this function is doing. It does. If you don't add doc string, nothing will happen. But doxing helps to the other developers, or someone is who is seeing this code will understand what this method is doing, because it's not like there is only one line. In real world, there the function can be 50 60 lines deeper, and each can be linked to another functions also. So that's where the logic and what you want to do is should be there in the docstring. So we can write this method is printing, it's, or we can say it's greeting the user. Okay, so this method is greeting the user. So basically docstrings helps to understand what this method is going to do. So three things: keep functions name meaningful, one function always be assigned one responsibility. Every time we should use docstring. So these are the three best practices that I can think of now. You can add in the comment section what else best practices you follow or you find somewhere. Okay, so that's it. In the next section we are going to see a really important and a bit tricky topic, which is decorators. In this section we are going to see about decorators. It's a very important topic. Okay, in whether it is in interview or in the real project, decorators are heavily used. If you also worked in some open source project or in any project, decorators are heavily used. So in this video, in this section we are going to see about decorators. So let's see what actually decorator is. Decorator is basically a function that takes another function as an input, adds some functionality to it, and returns a new function without modifying the original function's code. It's a clean way to wrap the behavior around a function. Imagine we have a gift, which is a function. It remains the same, and we have to add some functionality. So we wrap it to look to make it look beautiful or to make it look anonymous. And that wrapping is a decorator which adds some presentation. So we had a function, we add some wrapping, which is we have added a decorator and added some enhancement to that gift, which is our function, and we added some presentation. So it take the decorator itself is a function which takes another function as an input, adds some functionality to it, and returns a new function without modifying the original function's code. Okay, so let's suppose you are having a function and you want to add the timings of that method. So instead of writing the timing code in any in each of the method, we create a decorator function that will take a input as a function. That each function it will take as an input, and it will calculate the execution timing of it, and it will return to it. Okay, simple. So let's see. I have created a seventh decorators.py, and let's first of all let's see what actually this is the syntax of decorator, and it's always remains the same. Okay, the syntax of decorator is we create a function names as decorator. You can name it as anything. Okay, it takes a function as an input, so we call it as, let's suppose we call it as original function. Okay, so we call it as original function, and then it creates a wrapper function. Okay, so it what the functionality that we are going to perform. So let's suppose we are adding a print statement here, like before the function call. Before the function call, what it should perform. Then we are calling the original function that we have passed. Okay, so original function we have called it. Now after this original function, what else functionality we have to add? Currently we are just printing something. Okay, after call. Clear? Then we will return this wrapper. Okay, so now our decorator is complete. Now let's suppose we have a function named as say hello. It can be any function. Okay, What this function do is just it prints something. Okay, let's suppose it prints hello. We want to add some functionality to this method. And what are the functionalities? Whenever I pass a function, I want to also print these two lines, before call and after call. So I can just add a decorator. Okay, and what was the decorator, or what was the function name? This was the function name. So I can add a decorator like this, at the rate and decorator. Whatever starts with that at the rate and we annotate into a function, we call it as a decorator. Okay, so this is our decorator function that we have created. Okay, so whenever I will call this say hello, so what will happen, it will also print hello, but before printing hello, because hello is being executed here, we are not. So what this mean, we are not, whenever we are calling this say hello, we are not printing this line, on we are not executing this function. This function is being passed to this decorator function here, and now this wrapper function will be executing. So it will print before call, then it will print the original function. What the original function says, say hello, sorry, hello. So it will print, first it will print before call, then it will print hello, and then it will print after call. Okay, so let me show you a very basic example. You can also code along with me. So let's suppose we have a method which is called as greet. Okay, so this greet method, which basically is going to do say hello YouTube. Okay, this is the functionality of this greet method. But let's suppose I want to add some functionality to it, and I want to print two lines. Let's suppose before greet and after greet. So I can add it here, like print before greet and after greet. But let's suppose there are hundreds of such methods. I want to add same thing to all the methods. So instead of writing the code here, I can create a decorator function. How the decorator function can look like? So it can be like, it can be named anything. Okay, it's not mandatory we name it as decorator. Modify grid, and it will take a function. So we pass a function here, and then what we are going to do, we are going to create a wrapper. Okay, then inside the wrapper, we will add some extra functionality. So we call it as before greet. Okay, and then we are going to call this function that we have passed. Okay, we have passed this function, print after greet. Okay, cool. And it will return the wrapper. Okay, and now if I call this greet, okay, if I call this greet, what this will print, simple, it will just print hello YouTube. It will not print this greet before greet and after greet, because we have not added the decorator here. So how we can add the decorator? Like this, modify greet. So now we have added the decorator to this greet function. So now it will print before greet, hello YouTube, and after greet. So basically we are enhancing the functionality of this greet without even modifying the code. We have just added a decorator. Now if I have another method like greet, sorry, def say uh, my say my name. Okay, say my name, and printing uh, my name is YouTube. Okay, even if I add, I can also add the same grid decorator here, and instead of calling greet, now I can call say my name. So here also the same functionality will be added, before greet, then the original function, and after greet, because first we call this function, then the function that we have passed this this function say my name, which prints YouTube, and then we have after greet. So this is the function, this is how we basically this is a simple demonstration of how decorator works. Okay, but maybe you might think that I was also thinking when I was learning about this decorators, why even we need this wrapper class? Okay, why can't we do like this? Okay, let me just remove these two lines for now. Okay, this was just for the demo purpose. Okay, so I was also thinking, I don't know, I was very dumb, or this is also with you. I'm not telling you are dumb, but I think lots of time we have this type of questions. So return, why we even need this wrapper? Okay, sometimes we think like this. Okay, so we are having greet, we have added a decorator, and we just printed, and we also executed the function. So we are also enhancing the capability of it, and then we are returning the function. But now let me just clear this all out. Okay, so in this case, maybe let me just also print entry point. Okay, so print entry point, because if you see what how the this whole program works, so it went to this line because this is a function, so it will not execute it. This is a function, it will not execute it. But now this is the first line that should be executed, entry point. Then this greet should be executed, and it should call a decorator, and it should print before greet and then hello YouTube and after greet. So what should be the sequence? Entry point, before greet, hello YouTube and after greet. Okay, but let's see what actually it is happening. See, it is printing before greet, hello YouTube, after greet, then it is coming to entry point, and then again it is printing hello YouTube because of this greet or not. Okay, so why this is happening? Okay, why we need wrapper class, this is the thing. Okay, why it is happening, let's understand. If you see this part, okay, what this part does is, okay, if I write it here, this line basically what it does is, um, it basically makes something like this: greet is equals to modify underscore greet, and it pass the greet. Okay, this whole line does this whenever we write some decorators. So this function is your greet function. Okay, so this function is your greet function. You are calling it right inside the decorator, which is why hello gets printed immediately when Python reads the code, even before you call greet yourself. Okay, we are not delaying the execution, we are calling greet at the same time when the decorator is being applied, which is during the script load time, not the run time. That's why these three lines are getting printed as the script is loading. It's not running at the runtime. And when we do this correction, okay, this is what I want to explain to you. Okay, but if we add some wrappers here, like def wrapper, and like this, and we return this wrapper only. Okay, wrapper. Okay, so if we do like this, okay, if we do like this, okay, now if I just run it, now everything is good. First we printed entry point, then we added before greet, then we added the function hello YouTube, and then the after greet. This was a good behavior which we were also supposing. Now after the correction, what it does is, how it looks like. Again, greet is equals to whatever the decorator that you are having, which is modify underscore greet and greet. And now again, thing is same, but it returns a wrapper because we are returning a wrapper. Okay, we are not executing it, we are waiting. It returns a wrapper. So this greet function is now pointing to this wrapper. Okay, this is at the same second time, this is giving a wrapper function. Now this greet function, whenever we are calling this greet function, basically we are not calling this greet function, we are calling this wrapper. Okay, this wrapper function, because at the runtime it returned a wrapper. So this greet function, whenever we are calling it, so indirectly we are calling the wrapper function. So the function is not called at the decoration time, it is only called when you are explicitly saying or calling the greet. Okay, so earlier it was directly, it was like greet is equals to modify greet, and we are passing the greet. Now greet is calling the wrapper. Okay, so that's why we are using helping, we are using another function which is a wrapper function. Okay, I don't know whether I was able to explain this part or not. Maybe this was not even in your maybe this was not even your doubt, but I feel sometimes this type of confusion, so that's why I was trying to make it clear. But if you are already clear in the previous explanation, it's fine. Okay, but definitely we need extra wrapper functions. Okay, and this was basic about decorators. You can explore more about decorators, how we pass args and kwargs, because maybe there is a situation where your function takes some arguments or args or kwargs, so we have to pass this args or kwargs here to these wrapper functions and all. Okay, it's not very complex, but you should also understand. But this understanding is really important to have, to understand what actually decorators are, and why we need a wrapper function here, why we need inside, why we need a extra function here. Because if you don't have an extra method here, then at the script load time, the decorator, or whenever you are calling the main method, it will call the decorator which is being applied. You are not delaying the execution time. But whenever you are trying whenever you are adding a wrapper function which is returning a wrapper function, so your main function should point to a wrapper function. That function is called at the execution time. Whenever you are explicitly calling the greet function, you are not at the decoration time. Okay, whenever you are calling this function, you are calling this wrapper function. Okay, the inner function, because this decorator is returning a wrapper function. Okay, I think this is clear. Okay, in the next section, we are going to see about recursions. Okay, so let's see what actually recursion is. So let me create. I'm not going to go very deep into recursion, because recursion is a very important topic. Lots of questions are there, because tree, graph, all things, all data structures are based on recursion. I'm just going to give you a very basic introduction where it can be helpful for your interviews or basic interviews. So recursion is a process in which a function calls itself to solve a smaller version of the same problem. A recursive function must have like a base case to stop the recursion, and a recursive case where the function calls itself. For example, you want to maybe count. If I pass a number like 10, so you want to count down like 10, 9, 8, 7, 6, 5, and once you reach 0, you are going to say blast off. Okay, so how we can do it? Def, okay, count down, and we are passing some numbers. Okay, simple, count down, and then we are trying to just print the number. Okay, print the number. Okay, and definitely every time we are trying to perform the same operation, but let's, because first time if I do like this. Okay, count down, and I add 3. So if I run it, it will just print 3. But I want to again do this with a smaller number. So what I can do is count down n minus 1, n minus 1. So first of all, it will go for 3 and it will print for 3. Then again it will call the same function but with 2. So it will print 2, and again it will call with a decreased number which will be 1, and it will keep going, keep going, keep going, keep going. But if we do this, okay, let me do this. Okay, see, maximum recursion depth exceeded, because it will keep going. See, count down n, so count down 3, 3 will be printed, then count down n minus 1 means again call that function for 2. Okay, it will print 2, then count down n minus 1, 2 minus 1, again call this for 1, and it will keep going for minus 1, minus 2, minus 3, and keep going. But that's why we need a base case to stop this recursion. Okay, that's why base case is really important. But we want to also check if if the value of n is equals to 0, then just print blast off. Okay, blast off and return. I don't want further execution. If I now run this function, we got 3 to 1 blast off. So what this mean? Count down 3. It went inside the function. It checked this statement. If n is equals to 0, no, n is 3. So it printed it. Now it again executed the same. It called the same function, but now with 2, n minus 1, 3 minus 1, 2. Again checked whether 2 is equals to 0, no. So it again printed. It printed 2. Now again it called the same function countdown with, but with a decreased value 2 minus 1, which is 1. So again it called the same function. 1 is equals to 0, no, 1 is not equals to 0. It printed it. It printed 1. Now again it called the same function countdown 1. Okay, 1 minus 1, which is 0. So now in this case, n 0 is equals to 0, so it will print blast off and it will return out of this function. Return is really, really important, and then it will blast off and the execution will be completed. So this is how recursion is helpful. Basically, recursion is a function which is calling itself. Okay, whenever there is a situation where a problem can be divided into sub problems, recursion is basically applied. Okay, whenever you will learn about when you will learn about data structures and algorithms, this is really, really helpful, because here this was a sub problem, because 3, first of all we have to do some operation at for 3, then we have to do for 1, then we have to do for 1. Sorry, first of all we have to do for 3, then we have to do for 2, then we have to do for 1. So everyone, at every step we have to do the same kind of we have to apply the same kind of logic. So that's why we can use recursion, because this is a sub problem. If we solve the sub problem, the whole problems can be solved. It's kind of a ladder. Okay, recursion. Okay, function is calling itself to solve a smaller version of it, we can say. One was a smaller version of two, two was a smaller version of one. Okay, of three, sorry. So whenever we are function is calling itself to solve a smaller version of the same problem, recursion is useful. Okay, and definitely we should have a recursive case. Here it was the recursive case. Here there was a logic, and we should have a base case to stop the recursion until, otherwise recursion will keep going. Okay, so that's all. We have seen also recursion. In the next part we will see some quiz, maybe 3 to 4 question on quiz, and then the whole playlist or the whole masterclass on function will be over. In this section we are going to see some quizzes. So here are some questions for you, some interesting questions that will test your understanding, whatever we have learned till now. Okay, so the first question in front of your screen is this one. So please go through and give it a go and let me know in the comment section what was your answer. So this, let me explain you this. So we have a method where we are passing args and kwargs, and we are printing args and kwargs. We are passing 1, 2, and name and age. So what should be the answer? So the answer should be, uh, it should print first a tuple, because args are passed as a tuple. So 1 and 2 are the positional arguments that we are sending as args, and kwargs are written as a dictionary. So names, a key, and age 25 should be printed as a dictionary. So this should be the output, tuple and a dictionary. Okay. So now let's move to the second question. So the second question is this one. Please pause this video, give it a go, and let me know in the comment section what was your answer. So now let's see the question. We have x is equals to 10. Then we have a test function x is equals to 5, and we are printing inside the x. So it should print definitely 5 because x is 5. And then we are calling this. We are calling this whenever we are calling this test function. We got x as 5, and we should print this. So x should be 5, and at the end, this x should be printed. So it should be 5 and 10, because this is a local scope and this is a global scope. If I run it, we are getting as 5 and 10. Simple. So now let's move to the third question and the last question of quiz. So it will test your Lambda function knowledge. Okay. So let me know in the comment section what was your answer. So we have a list which is 1, 2, 3, and we are trying to print a squad of this list. We are using map, which takes a function and a iterable, and what will be the value? So definitely it should print 149. I think we have already seen in our video only. Okay, so that's all. This were the three quizzes questions for you. Maybe you can go through more in on any you can say internet, uh, wherever you can find some questions on functions. You can go through it: lambda functions, recursion, decorators. Okay, and keep revising it, and this will be really, really helpful for your understanding on functions, as well as if you are preparing for some interviews, or if you are applying for Python developer. This can be really, really helpful. That's it. If you need some, if you have some doubts and you want to clarify with me, let me know in the comment section. If you have any complaints or any improvements, if you need some improvements, please feel free to post in the comment section. I will be very heavy or very happy to help you. And that's all. If you like this video, please subscribe to my channel, and definitely I'm going to uh, basically add this whole code into this GitHub repo, and then so that you can access it. Okay, in previous video I have just done this in front of you, but I think it will just increase the length of the video. I will add it to this GitHub, and definitely you can access it. And please, if you feel this uh, content valuable, please feel free to subscribe my channel. Thank you.